Hi, friends. I'm so sorry that I wasn't able to be there with you in person, but I hope that you enjoy the talk, and I look forward to answering any questions that you may have.
Welcome to Simply Serverless. A few months ago, I started a new position at Meetup. Part of my onboarding process was to review the backend architecture, and I started to come across designs that looked a bit like this. There were lambdas everywhere. I had a vague understanding of what they were, but nothing really too deep, and it made me more curious. I wonder how many folks here are somewhat familiar with lambdas. Hopefully you've at least heard of lambdas before. At Meetup, at one point we had over 1,400 lambdas in production. That fact alone made me decide I needed to wrap my head around this technology. My goal today is to help impart what I've learned so far to help you get started with your serverless explorations. One of the key things to note about lambdas is that they are just a small piece of what makes up the serverless landscape. I have to give props to Amazon because in many circles, Lambda is synonymous with serverless, but it's not actually a one-to-one mapping. Serverless encompasses storage solutions, authentication, queues, IoT, and much more. Here's how I like to think about the buckets of serverless services. There are four main areas which are vendor agnostic. The first is compute. This maps to functions. On AWS, that's handled by Lambda. Next is storage, with things like files and raw data. On AWS, that could be something like S3 or DynamoDB. Third is streaming, with messages and queues. AWS has SNS, the simple notification service, and SQS, simple queuing service, just as some examples. And finally, we have querying, like ETL, SQL, and ML. On AWS, there's tools like Rekognition, which handle image and video analysis based on machine learning. But what exactly is serverless? Does it mean that your code just runs on the air? Well, no, that's not it. It's mostly encompassed by three things. You have no servers to manage and provision. You pay for what you use. So instead of running EC2 instances and getting billed on an hourly or monthly usage, it's based on millisecond usage. And finally, scalability is provided by the vendor. You don't have to set up load balancers and auto-scaling groups. Get the health check triggers just right. It's all handled for you behind the scenes. When we think about the landscape of serverless architectures, it runs from two extremes, on-premise servers all the way over to cloud native. Cloud native is the ideal where the entire architecture is based off of events and triggers and take advantage of serverless services. Similar to this diagram that I showed you earlier, you have a trigger, the user taking an action on their device, and then there's this cascade of interactions that involve serverless services. The key players in the game are, of course, AWS, Google Cloud, Microsoft Azure, and IBM. But what is it that these vendors are promising us? Well, the main pros are the following. You get a faster time to market. As I mentioned, there's less things to configure. You have cost savings because you only pay for what you use. There's simplified scalability, no triggering with health checks and load balancers, and there's no need for specialized DevOps teams. The actual engineers who are working on the code can support this infrastructure. However, this does come with real cons, such as an ecosystem that's fairly immature. Lambda was only launched back in 2014. There's also vendor lock-in. Often, when you choose some type of serverless architecture, you end up going with one particular vendor for everything. There are multiple moving pieces. If you think back to that diagram that I showed you, there were lots of events and triggers and services that needed to work well together. And finally, it is a learning curve. when you're used to developing in a monolith architecture, you kind of have to shift your thinking in order to really adopt the serverless model. But in an ideal world, developing applications that take advantage of serverless services means less backend code, less complexity, less risk, and also less tech debt. But you have to be able to get those things just right. But how can you get started? Let's take a look. I recommend creating an account on AWS with the free tier. All of the major players have a very generous free tier, which allow you to experiment with serverless on your own. I chose AWS because that's what we use at work, and it is by far the key winner of cloud compute at this time. You can create a Lambda function via the AWS console, and you have a few options to do that, either from scratch, using a blueprint, or via a repository of Lambda apps. Let's take a look at the console to see some of the options that are available to you. Here we are on the Aws Management Console. You can see a list of the available AWS services. Let's choose Lambda. When that loads, you'll see a list of any functions that you've already created and that are available, but you have a huge orange button that you can create a new function of your own. When we click that, we see those different options that I just spoke about, creating something from scratch, using a blueprint, or browsing the app repository. I'm going to choose use a blueprint. When I look at the various blueprints available, there's things written in Node.js and Python, tons of Node.js and Python, and you can actually filter things, look for different tags. When you click on one of the blueprints, there may be some configuration options available to you. You can see some of the code that your Lambda will generate, and then you can create the function. It's really straightforward to get started with at least experimenting with Lambdas in the AWS console. So let's go back to our presentation. There are loads of services available from the cloud providers. This is just a snippet from AWS, and every time I check back, it seems like they've added another new service, so you have to do it often. Here's one from Google, a very similar story, constantly adding new serverless services that you can incorporate into your applications. Essentially, you need to be a good detective. As you're building your application, you have to constantly keep checking back to see what's available because it could impact the final solution that you choose. And that's a good thing. Another thing to keep in mind is that although running serverless can be cost effective, it's not actually free. You can use a tool like this serverless cost calculator to get a sense of what your application will cost you. For instance, it costs me 50 cents a month to run my sample app that I'm going to share with you. It uses API Gateway, CloudWatch, and Lambdas. Now, we've seen how we can use the console to deploy our application, but that's not actually the recommended approach. You want to take advantage of configuration instead. A platform-agnostic way to do that is by using Terraform. Terraform is an open source tool that lets you create infrastructure via code. Here's a snippet of a Terraform file. It has its own DSL for specifying the resources and data that will be needed by your serverless application. In this example, we can see use of AWS API Gateway method, some resources. We see that there will be GraphQL involved, etc. However, it's worth noting that each of the cloud providers has a proprietary way of doing something similar. AWS has CloudFormation, and Google has the Cloud Deployment Manager. Here's a visual tool provided by AWS for creating those CloudFormation templates. You can basically drag and drop the configuration that you want to use, and then you'll see below it shows you the template language and what the result will be. Ultimately, creating serverless applications requires a mind shift. You have to think about testing in production, focusing on split testing, preemptive load testing, observability of your system, having unit testing in place, and using that as the thing to deploy to production. You want to spend more time designing your system upfront than maybe you typically would have when working with a monolith application. Now that we have some foundational knowledge, let's take a look at serverless, but with Kotlin. We're going to focus on three main libraries: KTOR, Koin, and Kotlin. The goal is to create a GraphQL API that exposes UFO sighting information. First up is KTOR. KTOR is the application framework that we're going to use. You can think of it a bit like maybe the Spring framework that's been used for decades to deliver Java-based applications. KTOR's main components are an application class. This class consists of various features that can be included in your application. Now, normally these features would intercept either requests or responses and perform some action, like adding headers or changing the content type. There's also the concept of routes. The routes are used to provide handlers to act upon various request paths. Let's look at an example. In this KTOR app, there are two routes. The first is a GET request against the root path, and the second is a POST request against /GraphQL. Everything else is going to return a 404. Inside of the route is the code that you want executed. In this example, when someone hits the root path, I just want to redirect them to our index.html page. And then for GraphQL, I want to take their requests, process it, and then respond back. Let's move over to Koin. Koin is a lightweight dependency injection framework for Kotlin developers. It's written in pure Kotlin using functional resolution only. So no proxy, no code generation, no reflection. I really like to use it when I'm working on my sample projects. This is how you use Koin to inject the dependencies in a class. I really like it for simple things like this, just by inject. But finally, the star of the show is Kotlin. Kotlin is a Kotlin serverless framework. Now, it works by doing the following. It downloads Terraform for you, generates your deployment code, packs up the Lambda, and then deploys it to AWS. Basically, all of the heavy lifting. When you combine KTOR and Kotlin together, that normal application class that you would use for KTOR, you now want to extend the Kotlin base class, define some routes for it, and that's it. In your build.gradle file, there's a configuration section there for the Kotlin plugin. And this is where you're going to provide some just basic information to help Kotlin generate the correct infrastructure code using Terraform. So we start out, we have the Kotlin DSL, and inside there is our config and web app. And then this is where we're going to specify our AWS information. And this is where our Lambda code and our config is deployed. And I will show you that momentarily. And then finally for now, the last time I ran this, I had to set up Route 53 with a domain in order to have Kotlin work. I won't go through the entire process, but it was all referenced in the documentation. And then you run deploy. Within seconds, you're going to have a Lambda ready to go in AWS. It's really just that simple. And when I went to my app, it was up and running and I had the ability to process my GraphQL requests. Now, it might seem really magical at this point, and for someone who's maybe new to serverless, I know that I was really impressed that I could deploy something in Kotlin with such minimal effort. But if you're curious to look behind the scenes, it's not really that magical at all. The plugin parses your code in conjunction with that information that you provided in the config DSL, and it goes and generates a Terraform template for your app. This template has everything needed to deploy a RESTful app. Let's take a quick look at the sample app. Here we are inside of IntelliJ, and this is what I use to develop my sample application. And I'll just kind of point out some of the key pieces of information. First of all, we'll start with our app class. I mentioned that you have your base class and it needs to extend that Kotlin class. And the key thing here is that it defines some routes. So when we move over to the routes file, this is where we see our main routing being handled. And there's GraphQL. And then also the index.html is defined as a static page. And then this is how we're using a GET request in order to navigate there. Pretty straightforward. So from here inside of our routes, notice how we're going to reference GraphQL. And that's going to take us over to our GraphQL route. This is a post request against that /GraphQL endpoint. We get the information for our GraphQL query. And then we come here and we call schema.execute, passing in our query and any associated variables. Once we get the result, we respond in JSON text format. That's really it. This app is super simple and it allows you to basically have a Kotlin-based GraphQL API. I want to show you just a few more files before we move on. The app schema is also written in Kotlin. This uses a library, kGraphQL, where you can define your Kotlin GraphQL schema. And it just kind of goes through and sets up the different queries like sightings, a user, your different types that you're going to have, and then a description, which we will see when we look at the app. And then here is our build.gradle file. This is using Gradle script, so it might look a little different if you're not familiar with it, but then you can see the configuration information for setting up Kotlin, and then the dependencies on Ktor, Kotlin, etc. And then finally, I spoke about how what Kotlin does is generate the Terraform that you need. And then here's that Terraform file. There's a pretty cool Terraform plugin available in IntelliJ IDEA. That's the one I'm using here, so you can get that nice syntax highlighting. And then you can see all of the different pieces that go into specifying your Lambda for AWS. So if we switch over to the browser, I just want to show you. Here is my application running. This is where I mentioned the Route 53 URL. You can see that we have a query down here. We're using the graphical browser, and then I can run and get my UFO sighting data, which is really, really cool to me. So let's go back to the slides. For this app, I'm really only just getting started. I haven't had as much time as I wanted to dedicate to it. It's mostly just a monolith deployed as a Lambda at this point, and that's totally bad. I want to move it to a more standard serverless architecture with using DynamoDB as my data store, running off of an S3 push event. So I'll get there eventually. If you're curious, you can follow along at this URL. But now finally, for a little bit of tea, just my sort of personal observations of working at a company that uses so many Lambdas. One thing that I noticed is sometimes it's kind of hard to, as a client-side developer, to track down the code for a particular Lambda or who's responsible for a Lambda. I know in a more traditional monolith architecture, we're very used to like this team owns this app and this team owns that app. But when you start getting into the world of Lambdas, it's like, well, which team owns this function? And multiple teams might own different functions. So I just feel like there's something that we haven't fully figured out around ownership, and especially like if you have turnover on the team and things like that, there's something missing around ownership with Lambdas. I don't know if it's labeling or what, but I really love to see what emerges over time as more and more companies continue to adopt Lambdas. So that's just like one of the biggest things that I've really noticed working at a place that has so many Lambda instances in production. If you're curious, please grab the slides and check out the references. You can learn so much more about serverless architectures, really principles that you want to keep in mind when you're developing for cloud native architectures. And then I really encourage you, even though we talked a lot about what AWS has to offer, I encourage you to check out some of the Google Cloud Platform solution architectures. It was really fascinating to look at what's available on the Google Cloud side as well. So whatever it is that you're trying to achieve, there's probably some variation of a serverless service out there for you. I would really love to take your questions. If you want to send me a message on Twitter at BrownGirlDev, I'd be happy to try my best to get you any answers that you have. So thanks so much for coming. Or rather, thanks so much for watching.